These two wires look relatively similar, but are they the same? Data transferring solutions has changed a lot over the past decade. We used to use copper to send data from one center to another one, but that's not the best solution anymore. Nowadays, we use optic fiber, a thin layer of glass, to send data. But how does it work? I'm Hadi, and I'm going to tell you more about optic fiber. So stay with me.
One of the biggest challenges of stepping into the new tech of fiber optic was, of course, infrastructure. We needed basically a whole new infrastructure, rewiring all centers, cities, towns, and everything. Well, this has done recently in my area, and its availability is still limited. So let's take a look at other internet connection solutions. We've got ADSL, which I think everybody is familiar with, getting internet over telephone lines. Well, that offers a bit of disadvantage, and that is speed limits. To today's standards, it is so slow that you cannot even upload 4K video using ADSL connection. Of course, ADSL was a bit improved by vdsl, but the improvement that wasn't that much. The next solution is cellular networks. Well, obviously they're faster than ADSL and VDSL, but the problem is their latency. Those networks are not as stable as the ADSL or VDSL connections are. So basically, depending on the usage of the area, your internet connection can get faster or slower. One more thing that is considered a big problem with cellular networks is the latency. So it's not the best solution for connections that might require a lower ping. Then we've got optic fiber. I've already explained what it is, but now let's talk about the implementations. We've got several implementations of optic fibers. Most of these implementations do not deliver the optic fiber directly to the client. So there might be a cut in the middle where optic fiber is going to switch to the old school Ethernet or the copper wires or whatever you want to call it. Then we've got some implementations that deliver optic fiber directly to the client's house. We might call them fiber to the home or FTTH. In this solution, we might have several units in between the ISP and the user itself, but it's going to deliver gigabit speeds. I'm talking about 1 gigabit to 10 gigs. One of these solutions is called GPON, Gigabit Passive Optic Network. Yeah. In this implementation, ISP does everything, starting from the infrastructure, wiring optic fiber in the area, putting the units all together, and there's really nothing to explain except how it works. GPON is one of the cheapest fiber optic solutions available right now, and I'm going to explain why. But before we jump into the theories, let's move around the area and see the units themselves.
Now that we saw the distribution cabinet, we're back in the alley where all those 24-core fiber cables are buried under the ground. Now each street may receive one FAT box. For those of you who don't know what FAT box is, it's actually a box that splits all those cores and keeps them safe.
Well, obviously all the data is encrypted, which brings the question, where does all the data get decrypted? The device that does this for the client is called ONU. On the other hand, the connection to the ISP is done by the terminal called ONT. With all said and done, it's time to compare the connection speeds between ADSL and GPON. Well, these results might be different for you, but eventually it demonstrates the differences very well. The max speed I was able to get with ADSL was around 5 to 6 megabits per second. But with the GPON, I was easily able to get speeds around 400 to 500 megabits per second, both for upload and download. Well, obviously in the GPON connection, the upload speed and download speed are going to be parallel, so they're going to be equal. But wait a second, that's not the end of the story. Optic fiber technology is relatively new, and there are some developments still going on. So thanks for watching. I've recorded this video for educational purposes only, and I hope it was useful for you.